Butyric acid is a foul-smelling carboxylic acid. Butyric acid is responsible for the smell of rancid butter and is the main contributor of the smell of vomit. The most efficient method of production of butyric acid is by fermentation, but I've chosen to explore some chemical methods. In this video, we'll be making butyric acid by the oxidation of 1-butanol using a solution of potassium permanganate. For this experiment, you're going to need 14 grams of potassium permanganate, 1.5 grams of sodium carbonate, 6.2 milliliters of 1-butanol, 90 milliliters of 3% hydrogen peroxide, 2 molar sulfuric acid solution, and less than 50 milliliters of diethyl ether. This procedure is adapted from the isobutyric acid synthesis procedure found in Vogel's Practical Organic Chemistry 3rd edition. First, add 14 grams of potassium permanganate to about 275 milliliters of water. To fully dissolve all the KMnO4, you might need to warm the solution a little. To a large 1-liter flask, add about 1.5 grams of sodium carbonate. Dissolve the sodium carbonate in about 150 milliliters of water. Finally, to the sodium carbonate solution, add about 6.2 milliliters of 1-butanol. Some of the KMnO4 solution was then added to an addition funnel. Throughout the experiment, the addition funnel is repeatedly topped off until all of the KMnO4 solution in the beaker has been added. With strong stirring, all of the KMnO4 was added to the butanol solution over the course of about 3 hours. Shown above is a very simplified version of the reaction. The KMnO4 oxidizes N-butanol to butyric acid and is itself reduced to manganese dioxide. The sodium carbonate that we added earlier neutralizes the butyric acid to its salt form, which greatly reduces its stink. After the addition was completed, the solution was put in an ice bath to cool it to about 5 degrees Celsius. It was then left to stir overnight. By the next day, you could see that a lot of the KMnO4 had been reduced to MnO2 and had become brown. However, when tested by dipping in a pasteur pipette, it is possible to see that the solution still contains a lot of KMnO4. The KMnO4 remaining in solution was neutralized by the addition of about 90 milliliters of 3% hydrogen peroxide, which was added in small additions. In the interest of time, only a few of the dozen additions were actually filmed. After adding all of the hydrogen peroxide, a pasteur pipette is dipped in to verify that there is no pink KMnO4 color. Turn off the stirring and let the insoluble solid MnO2 sink down to the bottom of the flask. The MnO2 is then separated from the solution by vacuum filtration. The MnO2 remaining in the flask is washed twice with about 50 milliliters of water. The MnO2 is washed twice with about 100 milliliters of water. The filtrate is transferred to a beaker and the water is gently boiled off. The Erlenmeyer flask was washed twice with about 50 milliliters of water. As the solution was boiled off, it was transferred to progressively smaller beakers. This step takes a long time. Be patient and just keep it at a low heat. You'll notice at this point that the solution is actually a little bit yellow. This is likely due to MnO2 contamination. You should keep boiling it down until you have about 20 milliliters left. Transfer your concentrated solution to a separatory funnel. This was a separate run and the solution was significantly more yellow. Ideally it would be clear, but it's fine if it's yellow. The flask was washed twice with about 5 milliliters of water. Next, 5 milliliters of ether was added. The solution was acidified using 2 molar H2SO4. We are acidifying the solution to regenerate the butyric acid from its salt form. The butyric acid is less polar than its salt form and can be extracted from the water using ether. Add only small volumes at a time with capping and shaking between each addition. You'll need to keep adding the sulfuric acid solution until the pH is around 0 to 1. The pH was tested and it was found that the pH was around 0. The liquid portion was transferred to a beaker. The remaining salt at the bottom was shaken and washed with 5 milliliters of diethyl ether. The ether washing was then added to the beaker as well. The solution was then added to a clean separatory funnel. The beaker was washed twice with about 5 milliliters of water. The separatory funnel was then capped, shaken, and vented. The layers were allowed to separate and the aqueous layer was drained into a beaker. The ether layer was drained into a round bottom flask. The aqueous layer was transferred back to the separatory funnel and it was further extracted 5 times with 5 milliliters of ether each time. The ether washings collected in the round bottom flask were then dried using a minimal amount of magnesium sulfate. The ether butyric acid solution was transferred to a dram vial and allowed to evaporate. The final yield was 3.75 milliliters of butyric acid, which represents a yield of about 60%. A distillation can be carried out to further purify the butyric acid and to remove the slight yellow tinge. This is the final and quite clean proton NMR of the butyric acid.